Hello, welcome to Pre-Technical Mathematics. This video lecture is on Special Products, Chapter 7, Section 1. Let's take a look at a couple rules first before we get started. You should be familiar with the distributive law. The distributive law takes the monomial and multiplies it by everything inside the parentheses. Now we have what we refer to as the difference of squares. Notice that this is an x plus a y and an x minus a y. When you multiply those two together, you end up with the x squared minus the y squared. Now, the perfect square trinomial, when you have an x plus a y squared, this is your resultant. It has kind of a cumbersome middle term. And when you have x minus y squared, again, it comes up with this kind of cumbersome middle term. I'm going to show you through this lecture a little trick on how to do this very easily and quickly so that you do not have to memorize these two equations. So just put these in the back of your mind. Hold it there for now. This one, however, is a real time saver, and you'll need to memorize and recognize it. When you have two variables with a plus and two variables with a minus, it is the first term squared minus the second term squared. Okay. This down here, two binomials, same first term. You'll have the x times the x, you'll have x squared. Your middle term will be the a plus b times x, and then the a times b. Again, I want you to just put this in the back of your mind for now, and we'll see how it plays out. Stick with me, okay? Let's see some problems. Here we have our first one. This is a monomial, one term, multiplied by a binomial, two terms. We know to use our distributive law to come up with 14 plus 7x. And that is the answer. Okay, here we have two binomials. Well, what do you notice? Take a look at them. We have 3a plus b and 3a minus b. This is the difference of squares. You should recognize it. Our answer was then the first term squared minus the second term squared. We should put a little parentheses around here because we also want to square that 3. So we'll end up with 9a squared minus b squared. Okay, very simple. Let's take this a little further. Okay, I've decided I don't like this one and don't want to introduce it at this time, so let's go on. Here's one for you. Now notice something. Look at it carefully. This is q minus f squared. What do you know about that? That is the difference of squares. So you should write this out as a binomial times a binomial. Can you determine what that is? Check in the course documents to compare your answer. Alright, here's our first binomial times a binomial. This is where I told you I was going to tell you a little tip to make this easier. Some of you are familiar with the term FOIL. It has been taught as first terms, outside terms, inside terms, and last terms. If you are familiar with this method, continue to use it. I'm going to show you my method, which may make it a little easier. Let me show you how it goes. What I do is I make a little smiley face. I'll put two eyes up here. Okay. Now we multiply 5 times the x, and we get 5x. I'm going to make another little smiley face. And I multiply the x times the 7. 7x. Now I add these terms. 7 and 5 I think is 12. That is my middle term of the trinomial resultant. I take my first terms, x squared, this is positive, and I take my last terms. 5 times 7 is 35. That is the trinomial answer to multiplying these two binomials. I don't have to remember first terms, I don't have to remember outside terms, inside terms, figure out which one it is. I just kind of am very lazy and make my little smiley faces. It goes very quick and easy once you get used to it. Alright, let's try it again. Okay, here's a little more complicated one. I don't want to fool around with this inside-outside terms. I'm going to make my little smiley faces. Come on, I need a second eye there. Okay. 2 times 3 is 6x. The eyes are completely optional, of course. Here's my second smiley face. 5 times 4 is 20x. I add them to get my middle term. 26x. Take my first terms, 12x squared, and my last terms, 2 times 5 is 10. And there's my answer. Now notice that when given two binomials like this, your first term will always be an x squared, unless there's an exponent here, but it will always be an x squared. Your middle term will always be an x, and your last term will always be a numeral. Okay, your turn. Now don't get upset with that being an A. Consider that an X. Use your FOIL method or your smiley face method and determine the trinomial. Alright, have to briefly examine cubes. X plus 3 to the third. What that is x plus y times x plus y times x plus y. Now you can simply do this with smiley faces, get an answer, and do it again with smiley faces, but you won't see these too often. My recommendation is to write these down somewhere, and then when you end up with a condition like this, follow the format. I'm going to show you how to do that in a couple slides, but we are not going to dwell on cubes. This is the sum and the difference. Okay, here's a cube. All right, now our formula said, let's see, let me just write it down. X minus y cubed equals x cubed minus 3x squared y plus 3x y squared minus y cubed. Now our x and y in this case are an r and an s. So that's our x and that's our y. Alright, so we have to take the first term cubed. We have 4r, so we want to take 4r cubed minus 3 times 4r squared times s. That's a minus s. No, we just leave that as s. Okay, it's a positive s. Okay, then plus 3 times 4r times y squared, so we have s squared minus s cubed. Now I know those look like 5s, but remember that they're s's. Alright, long drawn out, again just follow the formula. So 4r cubed, we cube the 4 and we get 64r cubed minus 4 squared is 16 times 3 is 48 r squared s plus 12 r s squared minus s cubed. Alright, now let me take you through one more that puts it in this format, and we will end up with the cube. Alright, here we are. Recognize the other format. H minus 3 cubed, h squared plus 3h plus 9. Okay. that simply becomes the first h cubed minus I'm sorry, 27 would be 3 cubed, 27. All right. All right, here's one for you. Remember the rule of difference of squares. Now you're working with the difference of cubes. Go back to that formula, write it down, and start putting in your numbers. That's the easiest way to do it. Okay, here we've got 3 binomials. It's going to take us a little time, but we'll take the first 2 first. We're going to apply our Smiley method. 2x becomes 3x. We have an x squared, and 2 times 1 is 2. Now we're going to take that term and multiply it by x plus 3. So we have x times x squared gives us x cubed. X times 3x gives us 3x squared. X times 2 gives us 2x. Now we have to take the 3 and multiply it by each term. So we get 3x squared plus 9x plus 3 times 2 is 6. Okay, did we get all the terms? I think so. So what do we have? Let's combine like terms. X cubed, and we have a 3x squared and a 3x squared. That'll give us 6x squared. And we have a 2x and a 9x, which gives us 11x. And then we have our remaining 6. Takes a little effort, but you get there eventually. Okay, let's see what we have next for you. Oh no, we're getting even more complicated, but what can we notice here? We have an x plus 4 and an x minus 4. We know that as the difference of squares. Did you pick up on it? So let's rewrite this as 5 times x squared minus 16. And we still have to multiply by x squared plus 16. Okay, now this looked real complicated, but look again. We have the difference of squares. So we keep our 5 and And we have x squared times x squared, which gives us x to the fourth minus 16 squared, which if I ran that through right is 256. Finish this off, gives us 5x to the fourth minus 5 times 256, which I got to be 1280. Alright, so what I'm trying to tell you is always look for this difference of squares. It saves you time. You don't want to go into the smiley faces because you won't have a middle term. So look for the difference of squares. That's the one I want you to recognize. Oh, I don't like this one at all. Let's see. We've got a plus b plus 2 and a minus b plus 2. If we rewrite this as a plus 2 plus b, we'll kind of put that in special brackets, and then we have a minus 2 minus b what do we have here? I'm sorry, that's a plus 2. These are the same. So we can rewrite this as a plus 2 squared minus b squared. Okay, so if we multiply this out, remember I told you I didn't like to memorize that square. I thought it was faster to do our smiley faces. So we're just going to do that very quickly. This becomes a squared plus 4a plus 4. And we bring down our minus b squared. That's our answer. Okay, so remember your algebra. Let's see, I think I've got one for you. Look at this. Now be careful. It's not as bad as it looks. Spend some time on it, and then check your answers in the course documents. This is the end of this video lecture.